In this video, we start section 4.1 and chapter 4. Section 4.1 is titled Elementary Number Theory and Methods of Proof. In this section, we are going to learn how to prove and disprove statements. We're going to talk about the definitions of even and odd, and also the definition of prime numbers. The theme of this chapter is how to determine the truth or falsity of mathematical statements. A math proof is a carefully reasoned argument to convince a skeptical reader that a given statement is true. So basically what this means is that in this chapter, we're going to be basically designing essays that convince somebody about the truth or falsity of certain statements. We call these statements theorems or axioms or whatever. Now, when I design my proof, it may look different than yours, it may look different than the book, but the content is going to be very similar. The statements I'm going to write or mention are going to be very similar to your statements, even though I might not use the same words. Just like an English essay, you may use different words, but you convey the same ideas. The content of a proof should be based on axioms, definitions, theorems that have already been proven. You cannot and you're not allowed to make up new mathematics here. You have to use axioms or definitions or theorems to get from where you want to go to where you have to be. For a proof to be correct, the writer must be able to convince the reader that every step along the way is based on true reasons. So it's a good idea to always mention the reason why you're doing something. Explain in details why certain things are being done. Most of the proofs that we're going to prove in this chapter are going to be either existentials or universals. And most of the universals will have a conditional attached to them. But that doesn't have to be the case always. In this first chapter, we're going to learn what's called direct proofs. Later on in another chapter, or another section I should say, we're going to learn other methods of proof that would be indirect ways of proving certain statements. This involves using proofs by contradiction, or proofs by induction, or proofs by contrapositive. There's more than one way to prove certain things. Now we begin with how to prove an existential statement of the form, there exists an x in the domain such that q of x. How do you prove and disprove this? Well, to disprove an existential, basically what that means, you're showing the existential is false. So, in order to show that the existential is false, you have to show that the negation of it is true. In other terms, in order to show that there exists an x in the domain such that q of x is false, you have to show that for every x in the domain, the negation of q of x is going to be true. And this is going to be a difficult task, but we'll talk about that later on. How do you prove an existential? So how do you prove one of these statements? There exists an x in D such that q of x is true. Well, what you have to do is basically provide the x. Or if you don't want to provide the x, you have to give me a recipe to help me find the x myself. Give me a set of instructions to show me how to find this certain x that works. Disproving existential is usually difficult because it involves showing that a universal is true. That's what we mentioned up here in this small paragraph. So now let's take a look at universals then. How do you disprove a universal? Well, to show that a universal is false, what you have to do is show that the negation of it is actually true. Remember, statements are either true or false. So if the original statement is false, then its negation must be true. And that's what the idea here is. And again, keep in mind that the negation of a conditional is not a conditional also. It's actually a conjunction. It's an and statement. So what do you have to do to find that the negation is true? Well, you have to find an x that makes p of x true but q of x false. This method is called the method of counterexample, disproving by counterexample. Now, how do you prove that universal is true? How do you prove that one of these things is true? This is where we're talking about in this section. We call it method of direct proof. So what you do is you find a particular but arbitrary element from the domain, and you assume that it has the property p of x. Then you show through your proof that the q of x property must also follow. This is what we call direct proofs. But like I said, there are other ways of proving statements that have universals. We'll talk about them in another section. The other option is to use the method of exhaustion. Another way of saying this is to say, do brute force, basically. So method of exhaustion is basically like a brute force. Just try the statement for every x in your domain. This works really well when your domain is small or finite. It doesn't work very well when your domain has infinitely many numbers, because you don't have enough time to try every number in the domain and show that that number satisfies your original statement.